For determining chloride in water, the standard method is a titration with silver nitrate. This is an expensive reagent, and so to reduce costs we're carrying it out in a microscale form here. The method works by counting drops of liquid that fall from a Pasteur pipette and then converting to volume. In this experiment we're using a 0.25% salt solution to stand in for your environmental sample and 0.05 molar silver nitrate. Instead of the normal potassium chromate indicator, we're using fluorescein, as it is safer both for us and for the environment. Assuming your pipette has been calibrated, and if not, see the video on microscale titrations, then fill your pipette with the silver nitrate solution, as full as you like. For the aliquot of our water sample, we're going to use 1 cubic centimetre again. Here I'm using a Pasteur pipette to measure it out, but you can use a graduated pipette or a micro pipette if you would rather. Add your sample to a small beaker or a test tube, in this case I'm using a plastic bijou. You can add the drops of silver nitrate from the pipette manually, but you and your pupils will have better control if the bulb is placed in the jaws of a laboratory clamp. You can then turn the screw to tighten the clamp, and it is easy to have enough control to be able to add a single drop at a time. Start adding your drops of silver nitrate, remembering to count them. When you add your first few drops of silver nitrate, you will see the solution starting to go cloudy. This is due to the formation of silver chloride. You will also see a brief hint of reddish pink colour which soon disappears. This is the colour of your endpoint that you will be looking for. As you add more drops, the darker colour will persist for longer, and you will need to add the silver nitrate only 1 drop at a time. Finally, a single drop will be enough to cause the colour to change permanently to the reddish pink. This is your end point. Take your total number of drops and divide by the number you got from your calibration. That gives the actual volume of silver nitrate that has been used. From there, you can carry out a standard titration calculation to work out the concentration of your salt sample.